So here's a very short video about how to use Taylor series to find limits. Okay, so remember this kind of problem that we saw when we were doing L'Hopital's rule. You want to find the limit as x goes to 0 of e to the x minus 1 minus x over x squared. You can't do it by direct evaluation because both the top and the bottom tend to 0. So we get a kind of 0 over 0 indeterminate form. And so in the past, we used L'Hopital's rule. There was no way of algebraically manipulating this expression so that we could just evaluate. So L'Hopital's rule just enabled us to differentiate the top and the bottom, and it says that the limit stays the same. We differentiate once, we get e to the x minus 1 over 2x, and we still have the same problem that the top and the bottom both go to 0. We differentiate again, we get e to the x over 2, then we can take the limit and we get a half. But what's interesting about Taylor series is it enables us to do the algebraic manipulation that we can't do because e to the x and 1 plus x are such different kinds of expressions. We can't in any way manipulate that. But if we write e to the x as a power series, we can. So let's try to do that. So let's replace e to the x by its power series, 1 plus x squared over 2 factorial, etc. Minus 1 minus x on the top over x squared. But now notice that on the top we can do a little bit of subtraction. The 1 over here cancels out with the 1 there. The x here cancels out with that x. That leaves us with x squared over 2 factorial plus x squared plus over 3 factorial plus all the other terms divided by x squared. But now all the other terms are terms in powers of x bigger than 2, so we can divide x squared through all the terms at the top, and we get 1 over 2 factorial plus x over 3 factorial, etc. And now this is a straight power series, which can certainly be evaluated at 0. So the limit of e to the x minus 1 minus x over x squared is the limit as x tends to 0 of this power series that we just found. And of course, all the terms apart from the first one are now just 0. So the limit of this is a half. So that's how we use Taylor series to find limits of indeterminate forms. Let me just say one comment about presentation. Often people would like to just write down the problem and just carry straight on to the answer. Here I broke it up into 2 steps. I first simplified this expression and then I found the limit. Of course, one doesn't have to do that. You can just go straight on with the problem, writing everything out, just making sure you include at each step your limit. So we just write out a whole series of limits until we get to the stage where we can take the limit by evaluation, and we do that and we get a half. So this is just one example. There are a lot of other examples, but they all pretty well follow the same pattern. It's just a matter of substituting the function for the power series for the function and then doing a little algebraic simplification.